and it can also be include a lot of things like, your values as well. Well, I want to make the world a better place whilst doing this. Maybe I want to. It's not just sufficient to solve one problem. I want to do it in a way that is ecologically friendly, for example, or I want to improve privacy of data as well while I'm doing it. So there are ways of making this vision more granular as well. And then your strategy is more like your engine, which is your sort of how are you directing your company, your projects at the moment? So it's the things that happen. Maybe you make decisions about this quarterly to decide, well, what are our core strategic projects? What are the things we're going to work on in these next few sprints? What's the next goal we're trying to get to? And your execution is then your day-to-day running of your company, like what's coming in, what clients are coming in, what problems are coming in that you need to solve quickly. And really the distinction is that as you go down this hierarchy, it's the frequency that you have to make decisions. And the challenge usually is a lot of people think about this the other way and start from the bottom, the execution, where you're worrying about everything that comes in day to day without actually thinking about what the long-term plan is. And if you sort of get trapped in that cycle, then you end up in this situation where you're constantly fighting fires and you're never really making progress. I mean, this has always been the case, but this is especially the case now with AI, when all of a sudden we can be bombarded by a lot of noise and a lot of decisions, and we can get fatigued quickly. So it's important that when we're making these decisions, we've got a clear direction for where we're going to, because ultimately, if you don't know where you're going to, well, how are you ever going to complete a journey? So we're going to go into a few AI topics now, and this is mostly a bit of a framing of the market and the history that has existed, that has led us to where we are today. So I'm sure most of you will have come across all of these definitions and perhaps even this Venn diagram on the right as well, which is AI is quite a broad term and is often used unhelpfully vaguely to describe pretty much anything that could be seen as a computer doing something intelligent. So a useful defining definition that we use there has come out of a textbook, which is performing tasks requiring intelligence when done by humans. But one of the challenges, obviously, is intelligence itself isn't very well defined. So we lead to very vague definitions when we describe things with AI. In general, we tend to look at things like our language models, processing language, processing vision, or making difficult decision tasks that are more than just rules-based decisions. We tend to think of that as AI. So then within AI, you find your machine learning. So this is where you train models, computing models, to learn from experience how to perform a task. And ultimately, this describes most models that we come across and use today fit within machine learning. And then within machine learning, you then even find deep learning, which is then the paradigm of machine learning that uses what we call neural networks. So these are then the networks inspired by human brains that, again, most of machine learning that we come across today uses deep learning. And within that, right at the bottom, you've got things like your large language models, your computer vision models fit as a subset within deep learning itself. So really a lot of what the market's talking about at the moment, these models, your ChatGPTs, etc., are really just quite a small part of AI. There is actually quite a broad area of other things within there and other research there as well. So then we've got like a little bit of history to sort of give a bit more context as to why now we're suddenly talking about AI. Well, I've sort of like to split it into about roughly 3 eras of history of AI. So I mean, we've really been talking about AI as a thing since really the first computers came about. So within the 90s, 40s, and 50s, there was a lot of academics who were pioneers in the first actual computers who started to think a lot more about well, what is the limit of what a computer can do? If a computer can make a lot of calculations, can I not make it there, break down any task that we do into some form of calculation and allow a computer to complete it. So in our images in the top left, obviously, Alan Turing was a big pioneer of this and wrote arguably the first paper on AI. But even if you wanted to look further back, you could argue that philosophers long before this have also tried to formalize how do you compute intelligence. So really, we've been curious as a species about AI since ancient times, and it's only really with the birth of computer that we started thinking about AI as an actual concept that we could build. So then sort of the next sort of stage of AI, this first stage was heavily focused on sort of logical reasoning and mathematical proofs. The next sort of stage came really when actually technology allowed us to do a lot more. So one of the limitations you have with logical proofs and logical structuring of intelligence is that it can be very inflexible, and you have to create a lot of rules and a lot of you have to create a lot of rules about the world for a model to understand it, which is just not possible for humans to do really on their own. It's far too much work. So what instead people started looking at was, well, we're collecting now a lot of data. We're beginning to get databases that can gather data, we can perform experiments and store all these data points in them. How can we instead like learn patterns within that data? How can we make predictive decisions? And this was really sort of a really big sort of advance in the sort of late 90s, well, mid to late 90s, and then into the 2000s. So some of the images you see on the left there, we've got Garry Kasparov playing IBM's Deep Blue in the mid 90s, which was one of the first AI designed to play a computer designed to play a game of chess against then Grandmaster world champion Garry Kasparov, and winning. But largely this achievement was down to sort of the volume of data that the computer had access to. It could recall information from every professional game that had happened, and then look at a board and say, well, actually, I can aggregate from this. I've seen this move multiple times. This tended to lead to victory, and this is where predictive analytics was shown in an interesting showcase. And some of that technology was then taken on and used in various ways in things like retail, for helping people understand what products to buy, how to sell things in their shops. But it wasn't really satisfying because people argued, oh, it's just I've got a lot of data. So the other picture is actually Lee Sedol, who this is the world champion at the game Go, which is another board, essentially tabletop board game, if you describe it that way, strategy game, in which there are far more moves than in chess that are possible. It's in fact impossible for a computer to store all possible board states of that game. So the argument here was, how can we go beyond just a computer storing and brute forcing it? How can we get them to understand important things about the structure and strategy of a game? And that is really what AlphaGo demonstrated. It demonstrated an ability to see patterns in the game that humans couldn't. It famously, within one of these games, made a move that all the commentators and experts thought was a mistake. They had to double check it before committing the move. And then 10 moves later, it turned out that move had been the winning move. So it really showcased the idea that actually there are limits to what we can process as humans with our brain, how much data we can handle. And computers are really good at digging into that data, finding patterns, and sort of making a decision based or giving some support to a decision based on them. So in this era, we also had massive advancements in language models, in vision models and everything, which sort of leads us into now where we are in the 2020s, which is the era of generative AI, agentic AI, and really like applications. So it's technology that now has massively changed the playing field. We can suddenly access unstructured data and extract insights from it far more easily. We can collect data that we couldn't collect before, but we haven't sat down and looked at what challenges we have across industries and said, well, okay, how are we going to use it to tackle some of our pressing challenges? We still have we are still looking for like the number of promising use cases that will really take off from there. And that's an exciting time, really, if you're in a startup, because it means there's plenty of opportunities to explore. So a little bit of a recap as well on machine learning and what's changed here. So traditionally, what you would have had to do if you wanted to have an AI solution in the past was, well, I have to use machine learning. I have to train this model myself. So I need to take a load of data, sets of inputs. I need to put it through my model and I generate an output, and then I evaluate that output against what the actual answers should be. And I start this learning loop, which trains the model to get better based on this example data on the task that I've given it. So when that comes to things like language processing, for example, like your ChatGPTs, that means that you need tons and tons of data, billions of pages of data to train that model. You need to then train it for significant amounts of time. You need the hardware to train that as well, and the costs skyrocket. So in the 2010s, there was companies that were looking to train their own model, was spending millions and millions on just training these models without necessarily having an end use case at the end of it. And that is basically, that is out of the realms of possibility for pretty much any startup. So it was a barrier that we couldn't really overcome. We couldn't use these models because we couldn't build them, because we couldn't afford to build them. We couldn't afford the technology to do it, and we couldn't get the data to do it as well. So what's changed now? Well, actually, there's a lot of companies now that have invested in that and created these models, and now they're available either via APIs or as open source models. So that suddenly means that actually the cost of using this technology for a startup has decreased significantly, because the main cost, which was training the model, gathering the data, has been consumed by someone else. So all of a sudden we can start looking at these capabilities that were beyond our reach before. How do we take information from text? How do we take information from visual prompts? And how do we take them from audio prompts? So foundation models really is how we describe these, are models that have been trained to be good at a broad range of tasks within these sorts of domains, whether that's text processing, vision processing, audio processing, or often in other cases, it's also multimodal. It does a combination of all of these as well. So that really, as we're starting to discuss, changes the playing field for startups, because previously you'd have to do this process yourself. As I said before, you'd have to train all your machine learning models yourself. You'd need a massive amount of data. You'd need a massive amount of technology, and you'd be fighting for skills of people who are essentially research scientists, have large salaries. It's a major capital expenditure and a major risk. But now what we're looking at doing is we build on top of the things that already exist there, which means that we're really starting to look at machine learning models as commodities. They're operational expenditure. They're things that we can buy, pay as you go. We don't need as much data, and we can run arguably on leaner teams, because we don't need to maintain a team to maintain and build those models themselves. And it takes that whole process of that whole multi-year long process of training these models away from you as well. So it's quicker for you to get to an MVP that you want as well. So actually the risk of the model build has really been taken away from startups now. And it's really not thinking about the model itself as the opportunity. It's about, what are you building on top of it? What are you doing with that model that is going to be the distinguisher? So really that couples into the statement of, what is your vision? How is your vision distinguishing you from everyone else that is building on top of these models as well? So we're going to talk a little bit about value propositions in here and what might make you stand out more than other people building as well with AI. So the challenge that we face now is, as discussed now, this is a lot more accessible to people. So we have built a market where thousands of products are being launched weekly to the point where buyers don't really know they don't really know the difference between the two, and often there isn't much of a difference between two products. Like if they're built to solve the same problem, they've just used the similar prompts, then there isn't really much to distinguish between them. Um, Equally, it's now an expectation that products are AI powered, so it's not considered as a selling point anymore. You can't go to someone and say, "I've got an AI product that does this," because they'll say, "Well, my inbox is full of AI powered products that I'm being advertised that do this." So it's actually beyond just saying we're AI powered. It's starting to become a case of, so what do you actually do? What are you actually solving? What are your actual results? And equally, just adding AI to a solution that already exists doesn't really, it's not really an appealing enough offer for a market to change. So, for example, if you looked at things like CRM systems, like your big players like your Salesforce and HubSpot were very quick to adopt AI within their products. So it's no longer a distinguisher to say, I'm going to come in and build a CRM and mine's different because it has AI. The question becomes more about what are you using that AI for and how is it improving people's lives? So the sort of the guidance really here is to start focusing not just on AI as a technology, but on what it's delivering. So some examples are things like, well, hyper personalization within your CRM. You're collecting a lot of data on how customers are responding. How are we using that to personalize offers to people, for example? It's dealing with unstructured data at scale. So it's things like, we're collecting large volumes of data that would not previously be processed. How are we extracting the important insight from that data and giving customers something that they want? It's stuff like cross-domain challenges. Like one of the big challenges is people working in silos. So how are you helping people break down silos so actually there is information passing across their business rather than just being stuck in their individual buckets, and then orchestration as well, which is an interesting one that with the growing number of tasks and the growing number of devices that are becoming automated, becoming programmatic. Well, actually, we create a new challenge, which is how do we control them all, and how do we keep track of everything that's going on with them? So there's a whole interesting challenge there, which is also similar to the data at scale, but it's more like the devices and the processes at scale. And there are other examples of these as well. So some sort of key questions to kind of ask yourself about your value proposition is really these three things. And does your value proposition hold up to this? Is the task that you're trying to solve, is it too expensive for humans to do it, for example, or like would it take a large number of humans a large amount of time to do this, for example? And then is it too nuanced or unstructured for traditional code? Because the normal step that you take first is if I can program it and automate it with a rule, why would I need AI to do it? It's much quicker and much more reliable to do it with code if you can. So if you can do it with traditional code, then what you are doing is what you're creating is not really going to add any extra value. And then finally, does it involve more than just a simple calculation? So, like, I don't know, you often see examples of people using ChatGPT to count the number of letters in a word, for example. This is a simple calculation. You go along and count the number of times that character appears. It doesn't need to go through an AI model for you to try and detect that. And what you actually do by doing that is add uncertainty. So, is your problem actually adding anything with the AI? Is it needed, or is it something where you are just throwing it in for the technology, basically? So these are important questions to ask. And then one sort of big challenge that you often see at the moment is well, people think that they've made a really exciting startup idea. Like we've come across a number of companies who say, well, I've made a Copilot for coding, for example, or and ours is different because it integrates with this, for example, or I've made I've made something that creates images. And what tended to happen with these things is they got a lot of attention for a period of 2 or 3 months, and then a big technology company that's already creating the models suddenly released a version within their own functionality, and that company became worthless in an instant. So the real thing to bear in mind is that you are actually also, if you are developing an AI product, you are in competition with big tech, and big tech has a lot of control of the market already, and has a lot of money to throw at the problem. So they are focusing a lot on things that are horizontal tasks, they're cross-industry tasks, they're generalized tasks. It's your summarization, it's your image generation, it's the coding, it's anything that would be added to something like ChatGPT as a feature. If you are trying to create those features, you are taking a very major risk, because you are fighting against people with a lot of resources that are throwing money at that problem. So where does that leave the niche for you as a startup? Well, there are a lot of industry-specific tasks that are actively seeking people to solve these challenges. So these are often tasks that are very unique to one individual vertical. They often require a significant amount of domain knowledge that you can pick up, and often find people who are willing to help you co-develop them and provide their knowledge um, for the ability to solve the problem that they're having. So you want these to be ones that are relatively complex processes. They involve multiple steps, that there is a reason why generic models or current approaches don't solve them. And you also want them to be able to create, either utilize or create proprietary data. So data that is, you can start collecting, that is your own data, because that is going to become some of your value. And equally, you want them to be a problem that is high value enough for the industry that they are willing to pay for a specific solution for it, rather than wait for a future where some solution might come down the line in 10, 20 years. It's got to be enough of a pain that any solution you offer them they're willing to put some money next to it. So really, this is for you, this is the focus, is find how can you find these specific niches, and how can you create prototypes quickly that validate that people are willing to buy. So the rather contentious quote at the bottom is, we've seen a lot of this. There's a lot of people who push out products that are basically just wrappers of language models. And if you are just building something like that, I mean, it's nice to do and it's good exercise, but I do not expect that you will make money or get investment from it, because people will not see a long-term route for it. So the final point really in this section is around, again, around the data, really emphasizing that point. So really, AI is an amplifier of your data. It helps you find patterns. It helps people find knowledge within their data, and analyze data quicker as well. So in that world, your data becomes one of your areas of defensibility. So it's important for you to know, well, what data are you already collecting? And is that data unique? And is it useful to help you get towards your vision? But secondary to that, you need to then think, well, actually, what new data could I collect that will help me get there? What proprietary data sets can I create? And ideally, things that are more creative, more sort of not static data sets, things like behavioral data, so user data, or expert created data, or experimental data. So I'll give a few examples of these. So In terms of behavioral data, are really, really strong examples of companies that built purely off this were, well, the loads of big tech companies really built off this idea. So Netflix, for example, understanding what data, what media people were watching, what people would like to see, allowed them to create a platform that engaged people more, that kept people, retained people, and offered them a product that was cheaper than alternatives. Equally, Amazon, in terms of providing a broad product catalog and directing people to what they needed. But specifically, this is really where Google and social media have really made most of their money, because they're not really they're not really selling a product directly to a consumer. What they are really doing was, or what they were really doing was selling knowledge and insights into consumers. What is it that people are searching for? What is it that people are talking about? What might you be able to advertise? And that was how they made their value. In terms of expert curated data, you might look at things like medical technology and think, well, actually, in order to know how better to diagnose people more quickly, we need to take expert data from physicians. This isn't a data set that is publicly available. That could become something that is a protected data set. And then the same with experiment data. If you're performing large scale experiments, so this could be it could be things again in medical and clinical trials. It could be any experiment that you want to take where you're going to get a result that that knowledge is new and it's not publicly available. You can build off that knowledge. You can use it to shape your product, but other people can't without coming and asking you for it. So you've got a gate to defend yourself with. And then equally, and this is kind of leaning towards as well, how you sort of keep your offer ahead, but also, I mean, if you are working in services, knowledge it's a distinguishing point. If you know a lot about a particular technology or how to deliver a certain outcome, how to use an algorithm, then you have an advantage. You're ahead of the people, but you won't stay ahead if you don't try and keep ahead. People are always chasing to try and keep up with that. And then importantly on the data point, we often talk about data quality and data quantity, and we can have some debate about which is more important, but they are both extremely important, really, because without quantity, your model's not going to learn anything. You're not going to be able to demonstrate things at a particularly large scale. But without quality, all you're doing really is amplifying nonsense. You're not really getting reliable answers from your systems. So I put together like a couple of just like what an example value proposition could be. So we have one here that is just imagine a sports team. I think this is something that's very easy for people to imagine. There's a lot of stuff going on a sports pitch. There's a lot of information that could be gathered that's all unstructured information. It's all things like GPS tracking, where are the players on the pitch, how many passes are being created, for example, how fatigued might someone be, what is their injury history. These are all places where you've created data that is not publicly available. You're generating a data set yourself that's proprietary. And really, this bit in the middle is where you start to add your value. Like you are creating your IP around how do you detect like tactics, for example. How do you select an optimal lineup? You are creating solutions in this area that are a lot more therefore defensible because it's trained off proprietary data. And then ultimately, the things that you're trying to focus on are well, how do I deliver impact for my users, and what are the things that they want to do? And this leads to things like in this situation, you might be trying to understand what actions they need help, what decisions do they need support making. It could be, when do I change formation? When do I make a certain tactical change? Do I want to, make a substitution now to prevent injury, for example? And then another example is returning to sort of the Netflix example. if you are collecting a lot of information on things like films and media, then you are also collecting a lot of information about how people are interacting with that media. So you can start to look at things like, well, in this middle section of this AI machine learning layer that becomes defensible to you, you are able to say, well, I can learn about what type of people tend to watch Marvel films, for example. That's knowledge that you've gained from people using your platform that someone who was to come and create a new website would not have that data. They would have to collect it themselves. So it gives you an advantage. And you start to be able to look at these sort of features in the middle about, well, okay, well, how do I start to recommend the right films to them? How do I start predicting what they want to view next? And equally, as we discussed, like with Google, well, how do I present the right adverts to them, maybe? So ultimately, the goal really for you is to try and get find a use case that is really high in pain or high in value for the high in pain for the user, isn't it? Something that's painful for them, or it gives them a lot of value, and it's something that happens quite frequently. So the real things to start asking yourself about any idea you have is, well, how much time and resource does it take to deliver the task at the moment? Or is the task maybe even not possible at the moment? If it's not possible at the moment, well, how valuable is it to a user for it to become possible? And then secondarily, then how frequently does it occur? Does it occur multiple times a day, once a day, maybe only once a week, or maybe even monthly, maybe only yearly? And what you're really looking for are these things that are high value, high pain. So I've put this little matrix here, and really you're looking for things that fall in this top right corner, this gold mine. And they happen a lot and they are very high value. That is the ideal project. But that's not to say that there isn't some value in the ones that are high value but happen less frequently. Sometimes there are tasks that use up such a large amount of resource that even if they only happen, for example, monthly, it is valuable to have a product that takes the pain out of them. So they're sort of more, I've labeled them more like an insurance bet. And then equally, things that are low value, but happen very, very frequently. There may be a bit of a risky bet, but at scale, these are things that could scale very, very quickly, because if you can get a large amount of users, a large amount of frequency at low value, you will still make a good amount. But this tends to be an area where there is a lot of competition, because if it happens frequently, people have often tried to solve the problem. So then I would talk a little bit about how execution's changed in the age of AI as well. So how do we actually deliver on our projects? And one of the major changes really is the availability of no and low code tools to develop prototypes. So the riskiest part probably of developing a solution is making sure that your solution is actually solving a problem. And there used to be a real challenge to actually being able to create a prototype and a working prototype and have people play with it and give feedback to it. What we have now with a number of these logos on the left there, and more are available. There is a lot of these platforms out there now, is the ability for you to suddenly get to a prototype very quickly. So if you can find a problem that you're trying to solve and you've got some people who are willing to help you test it, now you can generate a very simple solution very quickly and test it within that environment. And then ideally, find a way of iterating over that, so you know that you've got feedback from them that it's something that they now find valuable. So really what this is doing for the market, well, is because that is now so much easier and there's so much low cost, there is now that is one of the biggest contributing factors to a rise in the number of products out there. So what that really means for you is that, well, building the product is no longer the bottleneck. So it's no longer a case of you need to distinguish yourself in another way rather than saying I'm someone who can build products. You need to distinguish us by saying I'm building the right products that are solving a particular problem. So the focus becomes problem-led rather than technology-led. So equally, being able to build things quickly doesn't always lead to in a positive direction, particularly if you haven't done what we said at the start, which is got a clear idea of your vision and your direction, because there are sort of two major challenges that can happen here, which is one, I can build things now very, very quickly. So it's very easy for me to start adding lots of features to my product. No one may have asked for these features, but I might think I want to build them, which sort of creates this major risk that you're creating very, very bloated products. You're creating technical debt. There's a lot more things that you suddenly have to maintain, but what you've added isn't really adding any value to a customer. So it's important to really think about that before you you add a product. And equally the feedback loop, and because you can get feedback much, much quicker, it's possible to pivot much, much quicker. So if you didn't get the right answers or answer the right questions, and you lose confidence in what you're doing, then all of a sudden you can find yourself pointing in a completely different direction every week. And that's itself creates quite a lot of mental load and drain for development teams and for yourself making those decisions. And also hinders your progress towards a vision. So really, this is reiterating what having a good vision is the guiding principle that's going to keep you moving in the right direction. So it's becoming more about finding that problem, solving the right problem. So to summarize that somewhat in a little bit of a table format, so there are two parts that you've got here. So you've got the execution, which could be your agents, it could be your co-pilots, it could be your no-code tools. They're commoditized. Everyone has access to these. Everyone can build with them, and you're at risk of building this technical debt and overbuilding. This is your engine. This is your speed. Without the vision, the steering wheel on the right here, it doesn't really matter how fast you're going, because if everyone can move fast, it's only those people that are moving in the right direction that are really taking advantage of this. So it's really important that you get this vision nailed down. You know what it is you're delivering. You've got your path. So I put a little summary here then in governance and leadership, because as mentioned, this is sort of an area where there's a lot of appetite for people to develop in this area, but it's an area that is often overlooked at the moment. And fundamentally, there is still a large amount of disagreement around it as well. But some things that are core points and core challenges you will face in the leadership side, well, firstly, AI literacy is really important for anyone that you are giving an AI tool who's building with no code or low code tools or co-pilots. And it comes from it's a famous IBM quote, really, is a computer can't be held accountable for a management decision. So therefore a computer can't make a decision. And it's the same with AI. And an AI cannot be held accountable. So it's up to the users, it's up to whoever's using that AI to determine what is right, because they are ultimately going to be the ones that will be held accountable for it. So really, this sort of changes some of the language that you need to use with your teams or people who are using them. It shouldn't be about saying, I'm going to replace you, because that breeds complacency, or saying that AI will replace this work, because it breeds complacency and means that people won't review it. It's more about augmentation. How can you work with AI to perform the same task better or quicker than before, or both? So it's really about either reduction of chores, it's about augmentation of your performance, is really how we should be talking about the technology. And equally, this is connected to this is the oversight challenge, which is if I can create a lot of code or a lot of outputs very, very quickly, well, how are we checking to know that the output is as expected? And if we're not either monitoring this in some clear way, where we're saying we know what is expected of it, and we are monitoring that, or we are not having people actively sense check that, then we are adding a major risk into what we do. And then finally, for your team, it's really it's sharing with them a vision, because if they know what it is that is expected of them, what are the rules of using AI, and they know where you're trying to get to, then they are empowered to make these sensible decisions themselves, rather than switch the brain off and let the agent make the decisions for it. And then secondarily on this point is the governance and the safety rail. So we're talking previously really about leadership as your internal sort of governance, but in products that you are creating, there is a major appetite from buyers that you are thinking about governance, you are thinking about how trustworthy your product is. People don't want to buy extra risk for their business. They want to buy a solution, not a problem. So three main points on the right that you really need to think about is firstly, how is your product going to be auditable? A lot of industries are audited regularly. They need to show how they've reached a decision. So you need to break down any decision, any process into points where there is a clear audit trail that is trackable for every decision. It's useful to sort of ask yourself, how does a human currently do that decision? Can you map out that process and then look to automate it in a way that matches that human decision in some way? But it's also useful to make sure that you know how your model is coming to decisions and that it is effectively monitored. Then explainable AI is another point. So it's one thing to be able to generate an answer with a Copilot, but ultimately, unless you can explain how that decision was come to, people tend to not trust that decision, particularly in industry, in these where people are making decisions that are more risky, that are more auditable, that there's more governance over the top of. So if you want people to trust your tool and you want people to be able to use your tool, then what you need is also a way of explaining how this AI reached that decision, what were the important factors that led up to it. So as we said, the human that's going to take accountability for the decision is confident that this decision is right, or can can overrule the model if needed to. And then finally, benchmarking and monitoring is something that most people will already do in some form or other within developing machine learning models, but it's important to reiterate this. If you are building with AI for a particular challenge, you need to be able to know that your models are actually performing well, not just for your users' benefit, but for your development benefit. Because if you don't know that an update to your model has improved it, then why are you making that update is my main question to you. So the only way of knowing that is for you to be able to create some form of benchmarking data, some form of tests that allow you to validate your model's performance before you roll it out, but equally then to continually monitor performance, whether that's through user feedback or through other metrics, so that you know that any change that you make to your model is actually moving it in the right direction and not actually making your product worse. So to wrap that all up by coming back around to vision again, really, like, a lot of this comes down to really saying to yourself, well, what is it that I'm trying to do and how am I trying to do it is the takeaway here. We can use AI to get there, but if you don't know where you're going, how are you going to get there? And this is an interesting little thought exercise that I'm going to put out there for you to go away and think about. So if you're creating a startup, or even if you're thinking about a startup, I think you should do this little headline test, really, which is if you were to put yourself in a situation where you imagine a future, let's say in timescale that you choose, maybe 5 years, maybe 10 years, of where your company has grown and it's been enormously successful and it's reached the cover of a prominent magazine, what is it that the headline is saying? Is the headline saying about the technology? Is it saying we built AI, or is it actually saying these people prevented, maybe it's prevented, reduced the number of accidents by 50%? And I think really the important thing here is that in most cases, I would argue that people would be leaning towards this second one. It's the impact that's important, not so much the technology. Um, so hopefully you can take that away, have a little think about that, and think about really what is it that you would like to be known for, and then how can you use technology to reach that, rather than the alternative of how do I use technology to be known. Um, so thank you for listening. I think I've pretty much reached the end of my time there.